I'll show you another curve, okay. The equation r squared equals a squared cos 2 theta. Yeah. If you're doing this a lot, you can memorise the general shape of these and just draw them out, okay, if you're doing them a lot. But, you know, this is quite tricky when you first see it, okay. So, look, what I've done is just listed some angles. Now, because of the 2 theta, yeah, the angle's doubled, I'm going to put pi over 12 there, and pi over 8, pi over 6, pi over 4, pi over 3, pi over 2. Okay, and just like the previous example, I'm going to do it between 0 and pi over 2 and see what's happening. All right. So I can get it in the first, well, I know we don't have quadrants with polar coordinates, but let's pretend we do. If I can get it in the top right quadrant, that might give me a clue as to what's going on with the rest. Okay. So when theta is 0, so cosine 0 is 1, that's going to give me r squared equals a squared. So r is equal to just a. Okay. That's interesting as well, isn't it? That means the maximum possible value of r is a. All right. Then pi over 12, so double that, you got pi over 6. Okay. So cos of that is root 3 over 2. All right. So you got r squared equals root 3 over 2 a squared. So that means r is equal to wonderful. The square root of root 3 over 2 a. Let's work that out as a decimal, shall we? Okay, so that's the limit of my mental maths gone there for the moment. So root 3 over 2, hooray. Square root of that, okay, 0.93 a. Can I put 0.9a? Do you mind? Thanks. Next, let's leave it there because I've got a feeling I'll be needing it again. So double that, so pi over 4, so root 2 over 2, I'm going to call that 1 over root 2, okay. So r squared is equal to a squared over root 2, so r is equal to a over 2 to the power of a quarter, isn't it? 4 through 2. So let's just work out that is. So, yeah, and silly me, I forgot to take the reciprocal, so let's just do that. Power negative 1 equals 0.8, you happy with that? So I must say it doesn't go down in 0.1s, 0.84 that one was. Okay, and remember r is always positive, so that's why I'm not doing plus or minus, r is always positive with polar coordinates. Pi over 6, double that, so it's pi over 3, cosine pi over 3, great, it's a half. So you've got r squared equals 1/2 a squared, so r is equal to a over root 2, so it looks like it's not, it's 0.707 a, okay. Pi over 4, so double that, you get pi over 2, then you get to 0, don't you? Yeah. Cosine pi over 2 is 0. See how quickly that just went down? Okay. Yeah. That went down very, very quickly, didn't it? So that's 0. Okay. Next, you've got pi over 3, so double that. That's 2 pi over 3. Sorry, I'll work this out. Equals 2 pi divided by 3 equals your negative half. Oh dear. Oh dear. Can you see what's gone wrong now? It's not a mistake. This is part of the discovery bit, okay? I've got cosine of 2 pi over 3 is negative. Why is that wrong? Well, not wrong. Why is that causing a problem? Because if this is negative there, how is it possible you've got r squared isn't negative value? When r is supposed to be a positive number, not complex, it's supposed to be a positive number. Okay? Right, so that can't have a possible value, can it? Okay? Can't have a possible value. Are there any other values that won't be possible? Well, let's just think about this, shall we? Okay, so here we go. Let's just look at the cosine graph. Looks like this, of course. That's the cosine graph. So pi over 2, pi, 3 pi over 2, 2 pi, 1. So that's our cosine graph, cos x. Can you see that when we go from pi over 2 to pi, here to here, it's negative. In fact, when we go from pi over 2 to 3 pi over 2, it's all negative. So what it means is this is not going to generate any possible value of R4s, is it? Okay. Half that now, because when we want to have cosine 2x, because it's 2 theta, don't forget, that's going to be pi over 4, pi over 2, 3 pi over 4 pi. That's what the graph is going to look like, isn't it? So what that means is between pi over 4 and 3 pi over 4, there's no possible value of r. It's really interesting, isn't it? Okay, no possible value of r. Okay, so what shall I put there? How shall I write that? So I'm going to write something like pi over 4 less than no, yeah, no, yeah, go on. Theta less than 3 pi over 4 does not exist. Oh, no, does not exist. Okay, that's kind of interesting then, isn't it? Because I was hoping to find out what was going to go on between 0 and pi over 2. That doesn't possibly exist. Let's see what I can draw up. Okay, I am going to draw what looks like a traditional set of Cartesian coordinate axes, but they're not, they're polar coordinates. Okay. Right, so this pi over 4, that's really critical, isn't it? So I'm going to put that in as a dashed line there. There, that's theta is pi over 4. So what that means is between, let's put theta as 0 and pi over 4, I've got a curve that goes in here. Okay, it starts off at here, A, that's the maximum point, isn't it? Okay, it starts off there, and then it's going to spiral inwards to 0, because from here to here goes to 0, and it gets smaller and smaller, is it? A, 0.9a, 0.8a, 0.7a, then suddenly, bam, as if it's going to, so it's going to spiral inwards, okay? That way. I'm just going to draw it like this, because it's a bit better if I do it that way. And just that, because I know that's going to be an angle of 90 degrees. Whoa! That's not the best looking one, but there you go. I'm drawing that, okay? Right, so that's what the graph looks like between 0 and pi, and there's nothing there, is there? In fact, what did I say? Between pi over 4 and 3 pi over 4, so I'm just going to draw that in as well, okay? And theta equals 3 pi over 4. So that means I know there's nothing in that space there, okay? Sometimes knowing where there's nothing helps us as much as knowing where there's something, okay? Right, well, I don't need to do any more of the table now. Can you figure out what the rest of the graph looks like, okay, just from what we've got there? Maybe you pause the video, but from this hint, using what the equation is as well, okay, and what you know about the cosine graph, can you do the rest of the graph? Okay, done? Great, okay. Well, do you remember in a previous example I said what's happening with the negative values? Okay, so let's just remind ourselves of that. Cosine negative theta is equal to cosine theta. So what that means is between negative pi over 4 to 0, you have the same values, okay? So if I just put those as negative, okay, then these values of r are going to be exactly the same, okay? And I'm going to get exactly the same thing happening. I'm not going to be able to have anything between negative pi over 4 and negative 3 pi over 4. Oh, you should write them the other way around. Negative 3 pi over 4 less than theta less than pi over 4. Okay, so I'm going to continue these lines like this, you see. Theta is equal to negative pi over 4. And theta equals negative 3 pi over 4. Okay? And I know there's nothing between here and here. Okay? And I know that's going to do the same from here to here as it is from here to here. So remember I talked about reflective symmetry of the graph? This is just mirror image through there. Okay? So I'm going to draw that in, something a little bit like this. Have I done a good job? Oh yes. Sorry, that was me being pleased with myself. Okay, yes, I've done a reasonably good job there. Okay, so that's that. Okay, what is it doing over here? Because we know it doesn't exist here or here, but it does exist here. What's going on there? You probably have a guess. Okay, probably have a guess. Use the fact that that is r squared. Okay, use the fact that that is r squared. So what that means is that, can you see what that means? It means that you can have exactly the same going on over here as you are over there, purely because it is r squared. Okay. Or you could try it out. Okay, you put in values, table values between 3 pi over 4 and pi. Okay, and you'll find you'll get exactly the same values going on. Okay, and if you put it in between, you know, pi and also negative pi, I should say, negative 3 pi over 4, you'll get exactly the same thing going on. And remember, whatever goes on here is exactly the same as what goes on here as well, because it's mirror image from here to here. Okay, so what I'm saying is that r squared bit equals means that this is going to be reflected there, and the fact you've got cos 2 theta means that all of this is going to be reflected there. So there's two lines of symmetry to it. Does that make sense? I kind of hope it made sense. Okay, as I was talking about it, I was thinking, does that make sense? Okay, so you know, there we go. I mean, if in doubt, please just put in a number. Just put in pi. Yeah. Put in theta equals pi, and then cos 2 pi is going to be 1. You'll get the same, aren't you? Okay. Yeah. Maybe this is a better explanation. Okay. The one I'm about to give you now. Okay. The cos 2 theta means that between 0 and pi, you've got the same again between pi and 2 pi. I like that explanation a lot more, personally. Okay. I'll say it again, between 0 and pi, you've got another cycle of the cosine graph between pi and 2 pi. Okay. That's a much better explanation as to why the numbers are just repeated. Okay. Yeah, I'm happy with myself for that as well. So I'm going to try and do this as a mirror image as well. So here we are. So I've not done that well. I've not done that well. It's because that bit is not. No, I'm not going to do it again there. It's because that bit is not. That should have been a bit further out, but it's all right. Okay, there we go. That's what the graph looks like, which is rather nice, isn't it? Okay, which is rather nice. Okay. Have you drawn one of those before? I bet you have. Yes, you have. Yes, you have. Think about it. Think about where you've possibly drawn this symbol before. What is that symbol? Yes, another wow moment. That is the infinity curve. That is your equation for the infinity curve. Okay. It's called a Lemniscate. Let me write the name up. Okay. Lemniscate. Bit of a weird name. I prefer infinity curve for obvious reasons. But yeah, that's the infinity curve, which is really rather cool. Okay. I'm so glad that's still recording. Okay. Stand by, because I'm going to do something else that's cool with it as well. Okay. In another video though, because I'm trying to keep the videos relatively short so that the download speed is acceptable. Okay. But yeah, I love that. That's great. Yeah.